So there are two types of outliers on a very high level. So one type is univariate, so age based. So when we say age based, that means you are just focusing on one single feature, and you are actually finding who are the users who are like having very less age, or they are very young, and who are the users who are very old. So you are just focusing on one feature, so that is why it is called univariate. But let's say you have multivariate. So in case of multivariate, we have let's say two features here, and you want to find out maybe the animals which are like overweight or underweight, or maybe they are having the height also abnormal height. So maybe some animals are here, and most of the animals are having this kind of data distribution. So these are outliers in this case. So we can say we can detect outliers, right? So we can detect outliers based on various techniques, and depending on the type that we are having, this will change. So these are outliers right now, and these are normal values. So how do we detect outliers in case of univariate, and how do we detect outliers in case of multivariate? So we are going to see various techniques of outlier detection. So let's see those techniques now. So there are various ways. So one way is like you are using visualization techniques. So maybe this is good when we are having less number of features, but if you have too many features, then visualization techniques will not help much. So let's say you have box plot in case of numeric data, and you want to actually see how this overall the data looks like, how it is distributed. So in case you want to see that, then we will be looking into box plot. So we will have a separate session on the box plot, so you can have a look. But for the timing, just understand it is just a simple representation of the data, and we will see when I am explaining the hands-on. Then also I will be talking about box plot, and I will be explaining like what exactly it indicates. So we will be looking into box plot in the hands-on. So no need to worry if you are not very clear with the box plot. Scatter plot. So scatter plot is like this kind of layout, and here we can see this is having outliers. Scatter plot helps us in detecting that. And similarly, we have histogram for numeric data you want to see. So this is also very helpful. So in case of data visualization related discussion, then you will find histogram is also covered. So now we also have interquartile range based approach. So this approach is very much related to box plot. So in the hands-on, I will be showing you what is interquartile range and how do we compute it. So we are going to discuss this in more detail once we are done with the other approaches, like on a very high level. So definitely we are delving deeper into this, and we are doing hands-on regarding this approach. So that will be covered. And then we have z-score based approach. So this is like when your data is Gaussian distributed, and you want to take values between 3 sigma and minus 3 sigma, then that is z-score based approach. And then we have clustering based approach. You may use dbScan approach or maybe k-means clustering, and this is like isolation forest based approach. So these are various approaches. So the idea is like if you have univariate kind of requirement in which you want to detect outliers, maybe simple approaches are fine. But if you have multivariate kind of requirement, then you will be going for advanced machine learning based approaches of detecting anomalies. So this is a very high level introduction. So let's delve deeper into these two approaches with the help of hands-on. And then I will be also coming back to the whiteboard, and I will explain like what exactly is interquartile range and what is z-score. So we are going to discuss theory as well as hands-on in the next discussion.